In this example, we want to find f plus g, f minus g, f times g, and f divided by g, and then state their domains for the following two functions. So for the first definition, we know that f plus g of x is equal to f of x plus g of x. So that's equal to the square root of 3 minus x plus the square root of x squared minus 1. So therefore, there is our function for the addition. And now we need to find a domain of that function. Well, the first part, we know that 3 minus x has to be greater than or equal to 0. So that becomes negative x, which is greater than or equal to negative 3. And therefore, x must be less than or equal to positive 3. And then we also know that x squared minus 1 has to be greater than or equal to 0. So that means that x squared has to be greater than or equal to 1. So here we can see that the absolute value of x has to be greater than or equal to 1. So recall that the absolute value of x greater than or equal to 1 means that x is less than or equal to negative 1, or x is greater than or equal to 1. So when we figure out our domain, we can look at the value of positive 1 here, and then here is 3. And then here we have negative 1. So what do we know? We know that x is less than or equal to negative 1. So we know that it's less than or equal to negative 1. So there's negative infinity. And we know that x is greater than or equal to positive 1. And we know that x is less than or equal to positive 3. So therefore, they intersect in between here, and our domain is going to go from negative infinity to negative 1 bracket union bracket 1 comma 3. Okay, let's take a look at number 2. We have f minus g of x, which is equal to f of x minus g of x, which is the square root of 3 minus x minus the square root of x squared minus 1. So what would the domain of that be? Well, it's going to be the exact same as the first one. So again, the domain is 3 minus x is greater than or equal to 0. Subtract 3 to both sides, divide by a negative, we get x is less than or equal to 3. X squared minus 1 is greater than or equal to 0. X squared is greater than or equal to 1, which then becomes the absolute value of x, which is greater than or equal to 1, which means that x is less than or equal to negative 1, or x is greater than or equal to 1. So again, we know that x less than or equal to negative 1 is bracket going towards negative infinity from negative 1. And then we know that x is greater than or equal to 1 has a bracket at 1 and going to the right. And then x is less than or equal to 3 has a bracket at 3 going to the left. So we have the domain here of negative infinity to negative 1, including negative 1. And then the intersection is bracket 1 comma 3. Okay, next we have the multiplication. So we have f times g of x, which is equal to f of x times g of x. So we have the square root of 3 minus x times the square root of x squared minus 1. And so therefore, that is our result. And we end up with the same domain. So the domain is going to be the same. So it's going to be the exact same negative infinity to negative 1 bracket, and then union bracket 1 comma 3. And then number 4, we have f divided by g of x, which is equal to f of x divided by g of x. So that's going to equal the square root of 3 minus x over the square root of x squared minus 1. So now here is our function. Now we need to find the domain of this function. Well, we know that we have 3 minus x has to be greater than or equal to 0 from the numerator. So we should get x is less than or equal to 3. Now in the denominator, okay, we cannot let it equal 0. So now we can say that x squared minus 1 can only be greater than 0 and not equal to 0. So if we solve for x squared, we get x squared is greater than 0, which means, x squared is greater than 1. So we have the absolute value of x, which is greater than 1, which means that x is less than negative 1, or x is greater than 1. So the difference here of when we use our number line is that we have negative 1, we have positive 1, and then we have positive 3. So at negative 1, we have a parenthesis going towards negative infinity. At positive 1, we have a parenthesis going towards positive infinity. And at 3, we still have a bracket going towards negative infinity. So therefore, the domain of our function is going to go from negative infinity to negative 1 with a parenthesis, union parenthesis 1, 2, 3 with a bracket.